All right. Hey, everyone. Happy Monday. This is going to be the recorded lecture to make up for the fact that I couldn't be there to deliver this in person today. So as I mentioned last time, the focus of today's lecture is going to be inheritance, which was kind of the third reason for using classes and objects that I hinted at last time. But we didn't really have the time to get into properly. And so that's going to be the big focus of today's lecture is looking at inheritance and how classes and objects allow you to achieve code reusability in a similar way to what functions permitted us to do. So that'll be the main focus of today's lecture, but we're also going to go over a couple other important concepts now that I've introduced classes, including Python's pass by reference semantics um, and namespaces, as well as variable scope. So that's kind of a high level overview of what it is that we're going to talk about today. And with that being said, let's get right into it then. Okay. So I'm going to start with, we're going to start by taking a look at inheritance and what exactly that is. And in the interest of doing that, I'm just going to make a simple little toy example here to illustrate this. I'm going to make a new file that I'm going to call animals.py. And I'm going to make a class in this file that I'm going to call animal using the syntax that we saw last class. And this is going to be a very simple class, all right? It's only going to be going to be capable of doing a few simple things. So we're going to start as we always do with an init method to kind of build our class when we call it to make a new object. Remember this accepts self. And for this particular example, we're going to have it accept a species name as well for our animal. And what it's going to do is it's going to set this attribute, it's going to have a data attribute that stores the species name, which I'll also call species. And remember, this isn't an issue with the name conflict here because Python is able to differentiate between the two because of the fact that this attribute belongs to this class's or this object's namespace with the self keyword here. And so right? We're going to set that equal to the species that was passed as an argument. Um, and then the only other thing that we're going to have this very, very simple animal class do is maybe it'll eat things. Animals eat things, right? So we'll have animals and our objects will be able to eat food and we'll have it so that the food that it eats ends up in the animal's belly. And for that, we'll add another data attribute called the belly of the animal, which is going to start out as just an empty list. Okay, so here's our really, really simple toy class. And give me one moment. I will go to the right directory. And so if we actually try and play with this class a little bit, just to see what basic functionality we have here, I can import animals, and then I can make a new animal, which I'll call Mickey. And this will be a new animals object. And the species is going to be a mouse because Mickey is a mouse. And the actual scientific name for this is Mus musculus. Fun fact for you. Um, okay, so we can look at Mickey. We can see what his species is. He's a mouse. And at present, Mickey's kind of hungry. His belly is empty. So we can feed Mickey. I don't know what mice like to eat. They like cheese, probably. So we'll do eat some cheese. Has no. Oh, whoops. Sorry. This should be append. That was my mistake there. So there we go. I'm gonna just import a library that allows me to reload classes without needing to exit and re-enter the interactive Python shell. So you can just ignore this little line here. This is purely for lecture convenience. From import lib import reload, and then I'm gonna reload animals. Okay, cool. So let's try that again now. So Mickey is a mouse, animals dot animal, and it's a mouse. There we go. And so, okay, now let's have Mickey eat some cheese. some cheese. Now we can see, oh boy, how appetizing. Mickey now has some cheese in his belly. All right, great. Now, let's suppose I want to make another class here, and I want to call it a cat. Okay. And what I'm going to want out of this cat class is I'm going to want it to implement the same functionality as the animal class, right? We should be able to have our cat eat, right? Because any animal, a cat is a type of animal, should also be able to eat. And I could rewrite this eat method the same, and like exactly the same way in my cat class. But inheritance allows us to reuse the functionality and attributes of parent classes without needing to reinvent the wheel every time. So let's see how we can do that. So the way inheritance works is I'm going to say, okay, in parentheses now in this class declaration, I'm going to pass animal. And what this means is that the cat class will inherit from the animal class. So now what I can do is I can say, okay, init again here, will accept this. And we'll basically just, instead of the way that we can access the parent, because this class, because cat inherits from animal, animal is called the parent class of the cat class. And so now within this animal class, we can call the attributes, the both the data attributes and the methods of this parent class using the super keyword. So that looks like this. And what this is saying is just, okay, go to this parent class and call its method, like the name that I'm going to specify here after the dot, like this attribute, find it in the parent class. So I'm going to say, okay, call the parents init method and pass it for the species name, because it's a cat, we always know that the species is going to be uh, feline felidae, I think. If there are any biology people in the course who can correct me on this, I'm pretty sure this is the scientific name for a cat. Maybe it's not though. Uh, then please do, bring it to my attention. But I think this is. But the important thing is not so much the name, but I'm saying, okay, go to the parent class now. That's what the super keyword means. Get its init method. And rather than just passing it an arbitrary species name, because we know it's a cat, we can pass it the cat name. And we can also accept additional parameters in the child class constructor. We can maybe also pass a breed noun of the cat. And then we can say self.breed is equal to the breed that you give me. Okay. And then let's see right off the bat, let's see what this gives so far. Okay. Um, so I'm going to reload the animals. Cool. And now I'm going to have a cat that I'm going to call Tom. So Tom is equal to a cat or animals.cat. And maybe Tom, he's like a gray cat in Tom and Jerry, but I'm gonna call him a tabby because I don't know what that is, what breed that is. So Tom's a tabby cat, and we can see Tom is a cat is of type cat, but because the cat class inherits from the animal class, even though we didn't explicitly declare it in the cat class, Tom also has a belly, and it's empty, right? And Tom also has a species name, and it's, the scientific name probably for a cat. And so you can see that this class has just inherited the attributes from the parent class, even though I never explicitly declared that there was a species attribute or a belly attribute in the child class. And this is a really, really powerful, convenient tool. And moreover, as you can see, not only can we inherit and reuse um, the attributes that are defined in the parent class, but we can rewrite them to add functionality. Like here, we were adding, in addition to calling the parent constructor, which stores the species and initializes an empty belly, we kind of souped up the constructor in the child class by also allowing it to accept a breed. And we can see that Tom's breed here is a tabby. So we don't have to just redefine things in our child classes. Like we could also define a new method, like meow, maybe. Um, in our child class, which maybe just prints meow. And oh, sorry, one more thing I wanted to illustrate actually before we get into that is that it's not just the data attributes that we have access to from the parent class, it's also the methods, right? So Tom can eat because he inherited, like his class inherited from this animal class. So let's try that. We could say Tom can eat a, I don't know, a mouse. There we go. So if we look at Tom's belly now, you can see that it contains a mouse. Um, But yeah, the nice thing about inheritance is reusing code and customizing just the parts that you want to change to your liking without needing to reinvent the full wheel. So we could actually modify the eat method to be a bit more cat specific. And what I mean by that is, okay, eat is still going to accept food, but maybe we can check now if the food is equal to cheese, then our cat's going to pass on that because, cats probably they don't like cheese. So we could just say print cats don't like cheese. And otherwise, we will add the food into our belly. And I could call self.belly append food the same way that I was doing here earlier, but we really want to like reuse functionality because this eat method could be much more complicated. And so why reinvent the wheel when I already have it defined in my parent class? I could just call the parent method. And again, the way to call or reference an attribute defined in the parent is with the super keyword. So we would say super.eat, and then just pass it the food. Okay, so let's see what this does now. If I reload animals, invalid syntax. Hold on a second. It didn't like that. Oh, classic. Man, it's a good thing I don't have to take your quizzes, huh? I'd get totally screwed on the syntax mistakes. There we go. Okay, now if we reload animals, uh, there we go. So what was I gonna do? Right. I'm gonna make Tom a cat again, and we'll have Tom eat a mouse. Where was that? Tom can eat a mouse. And again, if we look now at Tom's belly, it contains a mouse. But if we try and feed Tom some cheese, right? Notice if we try and feed him some cheese, he's not going to do that. So even though we inherit the eat method from the parent class, we've overwritten it in the child class to add this new functionality while recycling the part of the parent class behavior that we actually wanted with this super keyword. Yeah, and so that's at a high level all there really is to inheritance for now. We could honestly like you can nest inheritance like this an arbitrary number of times. What I mean by that is we could have another child class called um, oh, I don't know. Like we could even have specific breeds, like a tabby, that could inherit from the cat class, and add some additional functionality on top of that. So now this tabby, and I'm not going to actually define anything here, but I'm saying that this tabby class inherits from the cat class, which inherits from the animal class. And then we could even have another class inherit from that one, and so on and so forth. And you could also have multiple parent classes in Python. But I'm going to postpone that until I'm going to postpone exploring that in detail until we actually look at dictionaries, either next lecture or the lecture afterwards. So for now, that's all there really is to know, or all there is to it, when it comes to inheritance. And of course, we obviously aren't restricted to just redefining things that are defined in the parent class. We could define a new functionality called meow, because obviously only a cat meows, right? Most animals don't, so it makes more sense to define it in this cat class. Um, Meow, and all it does is it prints meow, you know? Um, and so we can extend the functionality of the class with new methods as well, like the functionality of the parent class, I mean. And if we were to run this method, it would just print meow, as you might imagine. Um, yeah, so as far as inheritance goes, I think that just about summarizes what we should cover for the moment. Let me check my notes here to make sure that I've Covered everything I wanted to say on that. Oh yeah, I suppose an important thing to illustrate is just to really drive the point home, is that if we were to try and reload this, um, animals, and then maybe, we'll make that mouse Mickey again, who's just an animal and not a cat. Dot animal. Well, first let's illustrate the actual meowing behavior that we want. So Tom is equal to a cat of breed tabby. What did I do? Oh, it's because I didn't put the module. Okay. Now we can have Tom meow. Oh, see, I forgot to put self here. You always want to put self in your method names. Um, okay. So now if we reload this, and now we have Tom meow. We can see the Tom meows. Great, amazing. But if we have a mouse or, like just a regular animal object, Mickey, which is a animal, animals, animal type. There we go. Uh, if we try and call the meow method on Mickey, you could say, well, animal doesn't have meow. Only the child class does. So children can access their parents' attributes, but it's not true in the other direction, right? Like this parent class has no idea of what any functionality that's defined in any of its child classes. Like it doesn't have access to this meow method. It's one directional. From children have access to their parents' attributes, but not vice versa. Um, okay, so with that being said, um, let's move on to scoping now. So that was inheritance and code reusability, or the reusability functionality that classes let you exploit. Um, so now let's take a look at some scoping in Python. I'll make a new file that I'll call scope.py to illustrate this. Um, so we've kind of been a little willy-nilly in the course so far with where we defined our variables, right? Like if I have, let's say I have some function that does something really simple. It just prints a number, okay? You give me a number, and all I do is I print what that number is, okay? And then I'm going to say, let's define a number, which I'll call number one here, to be 5. And then let's call our print number method print number on that. And that's not what we want. So if I call or if I run this little silly little script that I've written here, scope.py, number is not defined. Oh, it's because I didn't. There we go. I just print 5, right? So, okay, great. But what happens if I defined this variable outside of my function, right? Um, but I could have also done it. What happens if I did it in here? If I do this now, or actually, let's leave number one out here and then define a new variable, which I'll call, hold on, this empty line's bothering me. Let's define a new variable now, which I'll call number 2, and I'll set that equal to 6. And then I'll also call print number 2. And here I'm not calling the print num method, I'm just printing number directly, okay? So if we run this now, then you can see it prints 5 the way that it was doing before. But when it tries to reference number 2 here, I get a name error. It says num2 is not defined. And the reason why this happens is because this num2 reference is out of scope. And what that means is the scope of a variable is kind of the block of code in which it is defined. And by block of code specifically here, I mean function definition. This num2 variable, because it's defined in the print num block, it is only visible to code that is part of the same block or within that block. If I make a call out to num2 outside of the scope of this variable in which it's defined, then I get a name error. Um, However, if I were to let's modify my print num a little more here, um, mess with it a little bit to maybe just always print num1, right? And when I run this, oh well, the problem is I'm still giving it positional arguments here. Okay, when I run this, I'm still, you can see before I get this big scary num2 is not defined error here, I'm still able to print 5 beforehand over here. And that's because um, this variable is defined outside of the it's defined within the same namespace is what these are called technically in Python as the function. And so it's visible. The things that you define inside this function are not visible to the things that you define outside the function, but the things that you define outside the function are visible to the things that you define inside the function. So scoping and visibility is nested in this sense. Um, yeah. And a namespace in Python, you can kind of just think of as a mapping of uh, variable or object names or references, but just think of it as a mapping of names to objects. That's all a namespace is in Python. And namespace and scope, for the purposes of this course and Python, can kind of be used interchangeably. You can think of the scope as the universe of a namespace. Um, like the so there's for this particular simple example that we've written so far, there's two different namespaces that we're talking about here. There's the namespace of the entire file or module, which is the global namespace. And in that namespace, we have printNum that lives there, the name of this function. Num1 lives there too. And then there's the actual namespace inside of this printNum function, which contains num2. Um, but inside this namespace or scope, you can still access the things that are outside of it in the global namespace. Yeah. And the other thing I wanted to illustrate with this is that it does nest, right? Like I could even define another function here. Uh, what should I call this? Maybe just add numbers. So we can have like what all this is going to do is it's going to take two numbers, in this case num1 and num5 and add them, right? So it'll just return num1 plus num5. Okay. Um, and now here in this print num, what I'll do is I'll print the result of add nums. So if I do this now, I'm going to get rid of this just so that it stops yelling at me. For this particular example, when I run this, oh well, I forgot to actually put the parentheses. Ah, there we go. When I run this, oh, I put num5. Whoops. Meant to put num2. There we go. So if I run this now, I get 11, right? Because I've created a new third namespace within this function that can see everything in this enclosing namespace of printnum and everything in the global namespace. Um, and so I can do this, but if I define some num3 here, which is maybe 7, and I try and print that instead of the result of add nums. And you can pause the video, see if you can figure out what happens if I try to do this. You could probably guess it at this point. I'm really like beating a dead horse right now. Um, I get a name error again because num3 belongs to this inner namespace, right? Its scope is add nums. Um, and so I can't access it from just print num, right? And so you can see that like what's the right way to how do I want to phrase this? It's like a Matryoshka doll, right? Like this is the innermost doll, and then there's this doll that contains it, and then there's this big doll that contains everything else. You know what I mean? It's nested in this sense.